Draw the diagram and all the forces. So initially we'll start like this. So initially, what is the state of? Okay, I think all of you. Okay, now we'll proceed like this. So this is the plank. First, there's a block in one. Acceleration of plank given. So let me write it. So what is the mass of the plank with the help of friction? Coefficient of friction between the bar and the block is mu. What maximum acceleration parallel to spring can the block given? So he has not given anything. So let me write mass of the blocks be m1. Next, this is m2, and this is the plank. Why lines are not coming? There is a plank and there is a spring connected. There is a nail. This is a situation. Now the plank is, I'll write it here. So there is a friction between, and initially what is the state of them? They are at rest. So we'll start problem like this. It'll be much easier. And what is the state of spring? Relaxed. Now I'll accelerate the plank. What maximum acceleration parallel to the spring can the plank be given, preventing sliding between the block and the bar? So directly, when the slipping between the blocks will occur, and this is rough is telling. This is rough. There's a friction between the blocks. Coefficient of friction between the block and the bar is mu, and there's no friction between the bar and the plank. Between M2 and plank, there's no friction. There's a condition. Now, as I move the plank, who will move the system of blocks? The spring force, because it is connected to the nail. No, this is nail. So as I start moving it, to shift it down. We'll shift it a little bit down. Yeah. So now as I start moving it, so let the acceleration of the plank, let it be A, I'll write it. So this is the acceleration of plank. This is what we are supposed to find out here. What maximum acceleration parallel to the spring can the plank be given, prevent sliding between the block and the bar? If plank accelerates, what will happen to nail? Nail will also accelerate, no? So this one end of the spring is I'm accelerating. Can you recollect similar problem just now I discussed? Just now, I just picked up the same problem in an order. So here, one end of the spring is what I'm pulling it, no, with an acceleration A, and instead of one block, we are having two blocks, and there is a friction between them. So just I'm correlating the idea what you learned in the previous problem. So work done by the spring in the plank frame, work done by the spring should be equal to what? Like a work done by the pseudo force on the like a block systems. So I'll write down this one. Work done. Initial kind. Select it will be work done by spring should be equal to work done pseudo force on the blocks. So work done by the spring is how much? Kxm square by 2. Work done by the pseudo force. Pseudo force alone, what will happen? It's going to pull them, no? Because the spring will become internal. The pseudo force is what will be acting on that one. So what is the work done by pseudo force should be m1 plus m2. I'll write it a naught into this will be xm. Keep in where we are writing in Planck frame. So here, what is the idea? Blocks will be at rest with respect to Planck. So you stand on the Planck. Who is doing this problem? Person here. You just appoint a person, let it be on the Planck. Then what he sees that the pseudo force will pull the block. And the work done by the pseudo force is what? Equal to increase in elastic potential in the spring. So I'm equating that one. So for what we have is this particular equation. Now let's come for in the ground frame. Let me take another person who is there on the ground. In the ground frame, what are the forces they will see? In the ground frame, what are the forces? You'll see that a spring force is acting. Then friction should act like this. And there's a friction. And there's no slipping between the blocks. There's no slipping between the blocks here. So therefore, any equation, can you write it? Kxm should be equal to, directly I'm writing it since we know this one. What is the maximum force for no slipping? This is the formula. Kx equal to mu m1 plus m2g. Now substitute this kxm value there and solve for that acceleration a naught. So here I think one more equation will come. Kxm by 2 equal to m1 plus m2 a naught. So this is equation 1, this is equation 2. Substituting 1 equal to 2. How much will get? A naught equal to mu g by 2. If acceleration of Planck is less than mu g by 2, no slipping will occur. If it is greater than mu g by 2, slipping will take place. I think the frame of reference very important.
Sir? Sir, F limiting would be mu m1g, no, sir?
Oh, I go back to block upon a block concept. When you apply force to the lower block, what is the maximum force for no slipping? Mu m1 plus m2g. Can you recollect?
Sorry, yes, sir.
Describe the motion of blocks with respect in the ground frame for no slipping occur. This is a condition. No? So I'll write it this. Who is this one? This person. Who is writing this equation? This one. I blue and red colors font also I'm giving it. There's a ground. And make it out this one. I'm scrolling down. Okay, one question will add up.